This is an animatronic that I made, and it takes the iconic painting of George Washington's crossing of the Delaware and transforms it into an interactive, animated, and innovative museum exhibit, which placed top 15 at TSA Nationals. But to understand how I got here, we first have to go back to the start of the school year.
TSA, Technology Student Association, is a nationwide competition which has over 40 high school events, ranging from fashion design to drones. I decided to mainly compete in animatronics. The competition is really open-ended, and the only design constraint was really a size limit. But all of these things were also needed for the animatronic to place highly, so let's jump right in. Before I could build anything, I first needed an idea for what to make my animatronic about. The theme was American history. I wonder why. My team and I brainstormed many themes, but they all had some issues. But then we thought, why not go back to how it all started? By turning a painting into an animatronic, we had full freedom to choose what to make animated. So after a few hours on Onshape, a few more 3D printing, the first rovers were created, which used a linkage to move all the arm dreads and the oars simultaneously. But those were only the rovers. What about George? With a character as important as him, we needed something special. We decided to go all out, stuffing 3 servos into him. One just spins an arm, but his neck is where it gets interesting. Using small micro servos and carefully designed parts like these gears, we were able to give his neck 2 degrees of freedom, so he can look anywhere. You'll see why this is so useful in a moment. Funnily enough, the mechanisms behind George and the rovers barely changed from the first prototype all the way to Nationals. I mean, if it isn't broken, don't fix it. But after states, we did add rotating heads and hip joints to the rovers to add more posability and motion. Okay, so now that we have the whole crew, it's time to make their boat. The boat was one of my favorite parts about this project, not only because it looks amazing. A big thank you to my teammates for this, who also has their own channel, which everyone should go subscribe to, but I loved the boat because it was really fun to CAD. Surface modeling is a type of CADing where instead of designing a part to be really robust or very compact, you're designing a part to have a more complex, smooth surface to give it the best aesthetic looks. Each iteration of the boat got closer and closer to the rounded, flowing, natural look we wanted it to have, and this final version, which used a lot of surfaces to create the exterior shell, was perfect. And after mounting all of the rovers to it and mounting it into the pneumatics with pneumatics? Yeah, so one of the requirements is fluid power, and because we didn't want to use hydraulics, we turned to pneumatics, which use compressed air to push and pull pistons. And there was a perfect opportunity to use them, which was to rock the boat up and down. Pneumatics are really the best actuator for this, because motors or servos would overheat under such constant use and having to hold up the weight of all this. So after hooking the pistons up to some air tanks, a pressure regulator, and solenoids, we get this. Yeah, the boat didn't exactly rock. So after doing some research, I found the best way to regulate pneumatic speed was by using an adjustable muffler. This controls how big of a gap there is for air to exhaust from the solenoid, which changes the speed that the air exits. And this changes the speed at which air can enter, which gives us the nice smooth motion that we want. Now the animatronic has essential pieces, but where's the Delaware River? That's the one mechanism I never got to work. The mechanism that caused me enough stress and frustration to take 20 years off my lifespan, and the mechanism that gave me PTSD, the wave mechanism. I needed the rotational motion from a motor to turn into oscillating vertical movement to push and pull a flexible sheet, which is designed to look like water, so it looks like it's moving. So it seems simple enough, right?
No.
But every single mechanism either pulled the waves as well as you could pull a push door, was as smooth as this pickup line, was as quiet as 4th of July fireworks, or was as durable as Anthony Davis. So, after trying everything I could think of, from a simple cam to crazy linkages to whatever this is, I never really figured out this mechanism. Each design had its own strengths and weaknesses, but by fixing the weaknesses of the previous design, I would encounter new ones, which were just as annoying. But this is the version that I ended up bringing to Nationals. It uses these circular tracks which rotate off center, sort of like cams, which drive these pistons through these pins, while being able to keep a solid axle which runs throughout the entire system. This was the closest I could get to solving the pulling, smoothness, and sound issues, but of course, one of these gears exploded 30 seconds into our presentation at Nationals. Wait, what's the camera doing here? This is a Raspberry Pi Camera Module 3, but why do I need a camera on the waves for the animatronic? Remember when I said George Washington's snack had some glorious purpose? This is it. The camera constantly runs a face tracking algorithm that I made using a model and a data set, which are already integrated in OpenCV, which made this a hell of a lot easier. But basically, by finding faces and doing some trigonometric math, which only looks complicated, and I might make a separate video breaking it down in more detail, but we can find the exact real-world coordinates of any face that the camera sees. And once that happens, we can do some more math to find the angle George Washington needs to move his neck to stare into everybody's souls. Make eye contact with viewers as he talks to them. Interactivity is another requirement, so we thought, why not have George Washington talk to the viewers? When the camera sees people, we jump into conversation mode, using hidden speakers and pre-recorded voice clips. Washington can explain the Revolutionary War to viewers. For Nationals, we even added the subtitle screen, integrated nicely into the front panel to be more accommodating. But now, how do we reply to him? Our first idea was to simply use buttons, but that was a bit boring and wouldn't feel like a conversation, so we added a microphone. Using a word recognition model called Vosk, the microphone finds if the viewer wants Washington to keep talking or not by looking at what words the viewer is saying.
Okay, so the camera's gonna load soon, and then we're gonna move over and the camera's gonna detect my face.
Hello friends, would you like to join us in our voyage across the Delaware River?
Yeah.
Let us begin properly. I am George Washington, Commander-in-Chief of the Continental Army. This night, Christmas night, we braved the Delaware River for a bold purpose against our enemies. Would you like to know what lies ahead?
No.
Then good fortune to you, my friend. Godspeed. Onwards, men.
Now that we have our main functionalities of the animatronic, it's time to add on all of the finishing touches, such as a second speaker to play background noise, LED lights along the top and the bottom, lots of detailing done with foam clay, painting everything, sewing clothes for the crew, some power supplies, a bunch more wiring, and then the frame as well. And now we have our completed animatronic. This was a really fun project to work on, but I won't be competing in animatronics next year. I'll be trying out a few different events, so if you'd like to follow along, please consider subscribing.